Bob uses 2 machines at the laundromat. Each washer costs $1.75. He uses 2 dryers, each costing $1.25. What is his total cost? So it sounds to me like he uses 2 washers and he uses 2 dryers, right? So you guys might say, well, that's $1.75 plus $1.75 plus $1.25 plus $1.25, right? You can do that. Or you can consider the cost of the overall wash dry. What is the cost of a single wash and dry? $1.75 and $1.25, right? Go. Say again? $3. And since there are 2 such cycles, a wash and a dry, you can simply multiply this 2 by the sum of these 2 items. Okay? Hope's already told us that it's $3 for a full wash dry, meaning that Bob spent $6 at the laundromat. So far so good, everybody? I know you're hot, so am I. That's example 1. Your textbook has a similar item. You and a friend are going camping. You each buy a backpack for $90 and a sleeping bag for $60. So 90, 90, 60, 60, right? You, the friend, whatever. Same exact thing, only instead of 2 cycles, 1 wash, 1 dry, we have 2 sets of supplies. A backpack and a sleeping bag. Well, that's all you need, awesome. Same exact scenario, okay? If you don't like doing it this way, there is also the method where you take each item individually and multiply it by the item cost itself. So there were 2 washes and 2 of those. You can do it this way as well. In the end, you're still going to come up with the same answer. Okay? So you can either add together the items and double it, or you can double each item and then combine them. You'll see that both items, or both methods, will give you the same result. Which leads us to what's called the distributive property at the bottom of page 71.
Attention varsity soccer players, there will be a soccer bus today at 3:30 to take you over to the River Road/Valley Field for all the players only. However, the bus will not be bringing you back to KTA after the game, so you'll need to find a ride home from the fields. Thank you.
The distributive property states,
Attention varsity soccer players, there will be a soccer bus today at 3:30 for all the soccer players only, going over to the River Road/Valley Field. However, the soccer bus will not bring you back to KTA tonight, so you'll need to find a ride home from the fields. Thank you.
okay, real quick, okay? I just wanted to make an announcement that there will be a soccer bus tonight, in case you weren't sure. So here we have it, my friends. Algebra, stated algebraically, the product of whatever A is and these 2 items is the same as multiplying the A by the first item and adding it to the product of A and the second item. Okay? Stated numerically, We did 4 times 6 here, and we're going to add it to 4 times 3 here. That is what the distributive property states. Now, right now, you might be thinking this really isn't a big deal to me, but when you start getting further into your career, this is one of the most helpful things I've ever used in algebra. Example 2, the top of the page. Guys, look at that geode, by the way. Total segue here. Look at that geode. It's in Spain, and you could fit 10 people in there. You guys all seeing that picture? I mean, that's legit. That's not in a museum. That is a real picture of people sitting in that geode there. 26 feet long. Kind of cool. So assuming you went to Spain, example 2 says you visit the gift shop and buy 3 geodes. Each one costs $5.95. Use the distributive property and mental math to find the total cost. Okay, this is the book example, okay? This is the book's example 2, and the reason I'm doing it is because I feel that you need more than one of these. So a geode costs $5.95 each, and you buy 3 of them. Use the distributive property and mental math to find out the cost. I don't know if you guys remember seeing this. I know it was somewhere in the red book. But to figure out what this costs, I would have to do $5.95 times 3, pencil and paper, or a calculator, right? Well, what if I rounded up to $6 and subtracted out the nickel and multiplied that times 3? And you're thinking, that's absurd. Maybe. But I know that 3 times 6 is $18. And I know that 3 times a nickel, let's make that correct, shall we, is 0.15. And I can do the math of this in my head. Let's see if I'm right. 1785. So if you don't have a calculator around, round up. So let's just say I wanted to buy 10 books. Okay? Each is $2.99. Okay? The cost of which is equal to $2.99 times 10, right? What if I round that up to $3 and I subtract a penny and multiply that by 10? Some of you are thinking this is stupid, but it will come in handy, I promise you. I use this all the time, and I never really realized what it was called until I started teaching. Anyways, 10 times 3 is $30, right? 10 times a penny is 30 cents. Would you agree that the cost of the book is $29.70? Okay, so books, geodes, what we did is we rounded up and subtracted to create the correct price. You don't always need a calculator, I promise you. All right, example 3. It applies to variables as well. Example 3. The book says, and you can look at this, use the distributive property to write an equivalent, the same, variable expression. What's up?
That's wrong. Yeah, it's wrong.
What? Is it wrong? 30
10 cents.
minus 10 cents, thank you, and 90. Thank you. It's wrong, lady. Thank you, thank you, thank you. All right. Example 3, use the distributive property to create an equivalent variable expression. For example, okay, there's going to be a couple of these. So if I say to you, take 9 and multiply it by the difference of 10 and k. Don't get all constipated about this. We're going to get through this. It's not too bad. Just follow along with me. Now you know that the order of operations says that we have to combine whatever's in parentheses, right? Well, you can't combine numbers with variables, which is why the distributive property allows us to multiply each piece separately. meaning 9 multiplied by 10 added to 9 times a negative k. Okay? 9 times 10, 9 times a negative k, which in the end is going to be 90, and I'm just going to plus a negative k minus 9k. Okay? That's one example of how that would work for you. Or maybe in the other direction, it might say 7 minus t multiplied by negative 4. Just because this number is laying after, you're still going to multiply. Negative 4 times negative t and negative 4 times 7. So it doesn't really matter what order you do it in. Remember that we learned about associating and commuting and multiplying. Well, that applies here too. I'm going to go negative 4 times negative 1t, which is going to be a positive 4t, right? Negative 4 times negative 1t, positive 4t. Remember, we don't know what t is, so all we're saying is this times t. Negative 4 times positive 7 is a negative 28. 2 examples to help you. Okay? That should have been letter B. Sorry. And if you, in the end, Stuart found one of these himself, and it looked something like this, or I pointed this out to Stuart anyway, I don't remember. 4z plus 6 is going to get multiplied by 8, negative. Since we cannot combine these two items because they're different, we have to use the distributive property to make an equivalent answer. The negative 8 must get multiplied by both pieces. Folks, if you are not paying attention, I guarantee you the answer you're going to give me is negative 32z plus 6, or minus 6. 8 negative has to get multiplied by both pieces within the parentheses. Okay? So that's negative 32z minus 48. Assuming my brain's not bleeding here. There's just a couple of examples. We are almost done, my good friends. Example 4. Yes, ma'am. How? Can you add variables to numbers? Can you add variables with numbers? No. 32z is a variable. 48 is a number. And you cannot combine things that are variables with things that are not variables. That's a great question, though. I hope you all heard her. This here does not equal 80z or negative 80z or negative 80 or any such thing. You cannot combine a variable, which is anything that has a letter attached to it, with a number. Cannot. Thank you very much for identifying and asking that. Okay. Last sample. If you need to look at my notes, you can, but I got to keep going. Find the area. So your book says area of a rectangle or triangle. You can look for their examples. Here's mine. Wow, you just slid off the side there. A says it's a triangle. This is mine. And the base is 10 and the height is 3 plus a. Can someone tell me the formula? I know Eli can. For area of a triangle. What? Grace. Good. Base times height divided by 2 is area of a triangle. Some people prefer to say it as 1/2 of whatever the product of the base and height is. Either of those things will give you that answer. So what is the product of the base and the height. The base and the height. Can we solve like we did in the previous 5 or 6 examples? The product of this and these 2 items. How did we do that, Rachel?
You do like 10 times 3 times.
Awesome. Simple. Same as the previous 1, 2, 3, 4, 5 examples. If you cannot combine these, you simply multiply that number by each item within and combine the answer. That is the answer. Is it meaningful to you or me? No, I don't know how big that triangle is, but I do know if I follow the instructions that I can give an answer related to the information I've received. That's a rectangle. Let's do another, or that's a triangle. Let's do another triangle. Here's another one. Yep. Oh yeah, cut in half. I forgot to cut it in half, didn't I? You can do it 1/2 of all of this, or you can cut this in half, which is 15 plus 5a. Boy, I'm really following this up. You can either say 1/2 of 10, which is 5. Okay, 1/2 of 10, which is 5, and then 3 plus a, thank you. Or you can do 30 plus 10a divided by 2. 30 divided by 2 is 15. 10 divided by 2 is 5a. 10a divided in half is 5a. All right, here's another one. Lost it. 6x minus 2 and 10. So the area is base times height divided by 2, or 1/2 of base times height. 1/2. What is the base in this scenario? Anybody know what the base is? We can sit. It's cool. Anybody want to tell me what the base is? Shout it out, please. 10. Thank you. 1/2 of 10 multiplied by what's the height, class? 6x minus 2. What's 1/2 of 10, folks? 5. Bravo. Can we find out what 5 times 6x minus 2? And how, Ethan? Right. What is 5 times 6x? Go ahead. 30 what? 5 times 6x, 30x. What's 5 times negative 2? Bravo. That's all you can say. You can't give any more than that. You can't say, well, the answer must be 40 or 20 or anything. You don't have any more. Here's the last sample. So that's area of a triangle. Now we're going to do area of a rectangle. Area of a rectangle. Rectangles are simply base times height, right? I did them backwards. Instead of doing rectangle first, I did triangle first. So let's do 8 plus 7b and a height of 4. What is the formula for area of a rectangle, Miss Jewel? Yep, or base times height. And the reason we say base times height is because the term length implies longer. I don't know. Base is 8 plus 7b. What is the height? Can anyone see what the height is? Go ahead, Sarah. How will we find the answer, Chris? Multiply what by what? 7 what? And what else? 4 times? Awesome. Why don't you give me the answer to that? Four times 8? Awesome. 4 times 7b. Bravo. That's all you can do. There's nothing more you can say. They did not give you enough data with which to give a logical answer. But the purpose of this whole exercise is you are going to use this distributing, this technique, to solve all kinds of things in your future, okay? It's not as hard as you think.